All right, y'all. Today I'm going to be talking to you about properties of exponents. So properties of exponents, you've learned it before in Algebra 1. You've talked about it and learned it again in Algebra 2. And then really in pre-calculus, we're just going to kind of go over some of the stuff you should already know so we can use it to kind of expand upon into properties of logarithms as we work through our unit this year. Okay, so the first exponent property we're going to talk about is our multiplying power. So if I have the same base, such as a base of A, and I am multiplying those two bases, then I'm going to add the exponents, m and ed, together. So as an example, if I have y squared and y cubed, I have the exact same base, and I am multiplying in the middle, so I'm going to add those exponents. So this would become y to the 2 plus 3, which we could simplify to be y to the 5th. Some things that you want to watch out for and be careful about. Let's look at this third example. We have c to the 4th times c to the 5th times c to the 7th. So multiplying all the way across, we want to add all the exponents. The most common mistake I see is saying this is c to the 16 by adding 4, 5, and 7. But we need to make sure we don't forget that c that doesn't have an exponent written on it, because it does technically have an exponent of 1. So this way it is 4 plus 5, which is 9, plus 1, which is 10, and then plus 7, which is 17. So this would, of course, be c to the 17. Last thing I want to talk about is a situation like this fourth one. We have 3c squared times c to the 12th times negative 4c times 2c to the 12th. So just like last time, I want to make sure I add this 1 onto the c. And just like before, we're going to take our c's. They're all being multiplied, so we're going to add the powers. So 2 plus 12 plus 1 plus 12. 2 plus 12 is 14. Plus 1 is 15. Plus 12 is 27. But then the other common question I get is, what do we do with those coefficients, those numbers being multiplied? We have 3, we have negative 4, and we have 2. Well, because those coefficients do not have powers on them themselves, we're just going to multiply them. So 3 times negative 4 is negative 12, times 2 is negative 24. So if we don't actually have exponents or powers on them, then we don't have to do anything special. So I'm going to let you go ahead and try the rest of these. So go ahead and pause the video now. You can try the last couple, and then I'll talk about them here in a second. All right, so we have that second one, c to the 4th times c to the 5th. That would be equal to c to the 9th. Then moving on down, we have our a to the 6th times negative 6a to the 12th. So the a's are the same base, so I add the powers of 6 and 12 to get 18. And the negative 6, I don't have anything to multiply by, so I'm just going to leave it negative 6. Now our 2 down on the bottom, notice how our bases this time, instead of being variables, they are numbers. Well, we don't treat them any differently. We don't actually multiply the bases together. So negative 7 to the 2nd times negative 7 to the 1st is not equal to 49 to the 3rd. It's still equal to that same base of negative 7 to the 3rd. So bases stay the same when we're applying our exponent properties. It's only the exponents that are going to change. And then last but not least, 3 squared times 3 to the 5th times 3 to the 11th. Base of 3 stays the same, and we add those powers together to get 18. Okay, let's move on to our next exponent property, raising a power to a power. So raising a power to a power is where we have an a to the m, and then it's taken to a parentheses power of n. We're going to multiply those two powers together, so m times n. So as an example, if I have y to the 3rd to the 4th, then that would be equal to y to the 3 times 4, which, of course, I could simplify to be y to the 12th. So this one is fairly straightforward. We don't have to do anything too crazy. I'm going to do one more just to make sure we're on the same page. So if I have x to the 7th, parentheses to the 5th, I do 7 times 5, which would be 35. So power to a power, we multiply the powers. So if you want to go ahead and practice these next couple, you can pause the video now. All right, so just checking in to make sure that we got everything correct. Y to the 3rd to the power of 8. 3 times 8 is 24, so y to the 24th. 4 to the 3rd to the power of 6. 3 times 6 is 18, so 4 to the 18th. And negative 6 parentheses to the second, parentheses to the fifth. 2 times 5, we get that 10. We don't have to multiply out that negative or that 6, so we just leave that all inside for our base. Remember, our base doesn't change when we're working with exponent properties. Okay. So next one we're going to talk about is dividing powers. So dividing powers, like our multiplying, it's going to kind of the same idea, but dividing now, instead we're going to be subtracting the exponent. So if I have a to the m over a to the n, then that would be equal to a to the m minus n. So I would subtract those exponents to get my value. So as an example, if I have x to the fifth over x squared, then I would subtract 5 and 2, so x to the 5 minus 2, which 5 minus 2 would be equal to x to the third. So nothing too crazy as we're working across these. All we're doing this time is subtracting the exponents each time. Let's do another one to make sure we're all on the same page. So let's do our x times y to the 11th over x to the 9th, y to the 5th. So I'm going to go ahead and add an exponent of 1 there for my x. Make sure that we're accounting for all of our exponents. So I have two sets of bases. I have my bases of x and I have my bases of y. So for my bases of x, I'm going to subtract. So x to the 1 minus 9 would be equal to x to the negative 8. And then y to the 11th divided by y to the 5th. That's 11 minus 5, which would be y to the 6th. And we're going to talk a little bit later about how we don't like negative exponents. But for right now, we're going to leave this one just as it is. So I want you to go ahead and try these last three on your own. So go ahead and pause the video if you would like. Try them each, and then you can unpause and we can check our work. All right, so we have a to the 4th over a to the 9th. Subtract 4 minus 9, that's going to be a to the negative 5th. Then we have our 5 to the 4th times 5 to the 11th over 5 to the 5th. So you can kind of do this in a couple of different ways. You could divide first and then multiply, or you can multiply and then divide first. I like to multiply first. So 5 to the 4th times 5 to the 11th, base stays the same, but I add the powers. So 5 to the 15th over 5 to the 5th, and that would be equal to 5 to the 10th. Then 1 over x to the 4th times x to the 9th. One thing to remember when we're multiplying exponents, and one of them, or not multiplying exponents, multiplying fractions, and one of them is not written as a fraction, we can write any whole number as that value over 1. So 1 over x to the 4th times x to the 9th over 1, 1 times x to the 9th on top, 1 times x to the 4th on bottom. We get x to the 9th over x to the 4th. Subtract those powers, 9 minus 4, and that would give us x to the 5th. Okay, so those are kind of our basic ones. Let's take it just up a little bit for some of our other ones. So power of a product and power of a quotient are both very similar. One has to do with multiplying going on the inside, and one has to go with dividing on the inside. But they both imply that if you have multiple bases with exponents on the inside of the parentheses, then everything on the inside ends up getting that exponent. So if I have a times b to the m, and just to make this a little easier to understand, I'm going to add that exponent of 1 on both of these. So if I have a to the 1 times b to the 1 to the parentheses m, then both of the pieces inside get multiplied by n. So a to the 1 times m, 1 times m is m, b to the 1 to the m, 1 times m is m. So it's like our distribution property, and it's the exact same thing for our power of a quotient. If I have a to the first and b to the first, and I have that power of m, even though I'm dividing, it's the same thing. 1 times m is m, 1 times m is m, so I end up with a to the m over b to the m. So let's look at an example and kind of practice this a little bit. So if I have b times c to the 4th, parentheses squared, I'm going to go ahead and add my 1 onto my b. So everything on the inside has that power to a power relationship that I'm going to multiply. So b to the 1st to the 2nd, that's going to be 1 times 2, so b to the 2nd. And c to the 4th to the 2nd, that's going to be 4 times 2, so c to the 8th. So really relatively straightforward, just like that. Let's do another one just to make sure we're on the same page. So negative 5c to the fifth, and I'm taking it all to a squared. So just to be sure, negative 5 is a base and c is a base. So negative 5 technically has an exponent of 1 on it. So negative 5 to the first, and then squared, that's going to become negative 5 squared. And then c to the fifth squared, 5 times 2 would become 10. So this would be c to the 10th. So go ahead and pause me right now so you can practice these last three, and then you can unpause me here in a bit. All right, so let's talk about these. So we have negative parentheses 5 to the first, c to the fourth, and that's all to a second power. So the squared is going to get distributed into the 5 to the first and the c to the fourth. So that becomes 5 squared and c to the eighth. I still have that negative on the outside though, so it becomes negative 5 squared c to the eighth. I want you to see the difference between those two. See how the negative was on the inside? So I took that whole negative 5 to the first and distributed the 2. So it's negative 5 being squared. In this example, the negative is on the outside. So the squared went to the 5 to the first, and then I can just multiply the whole thing by negative. So I just have that single negative out front. The second example, once I square negative 5, that's going to actually become positive 25c to the 10th. While this negative 5 squared c to the 8th, that's going to stay negative because the 5 is being squared with the negative on the outside of the parentheses. A really important key distinction. So then 2xy all to the third, all of those have a first power. So 2 to the third, x to the third, y to the third. And then 4x to the fourth y being squared, 4 and y with that power of 1. So 4 squared, x to the eighth, and y squared. So relatively straightforward. And we already talked about power of a quotient. It's very similar. So power of a quotient is same idea. Everything on the inside of the parentheses gets that power to a power treated to it. It's just dealing with the quotient instead of a product. So if I have 3 over 2, this is 3 to the first and 2 to the first. So that would become 3 to the fourth over 2 to the fourth. Oop, not 21 to the fourth. So relatively straightforward. Let's do one more together, make sure we're all on the same page. So if I have negative 7 over x, this is x to the first, and this is negative 7 to the first. So notice again, because I have that negative with my base, I'm sticking my parentheses around the negative. So this would become parentheses negative 7 squared over x squared. So go ahead and pause me again, and then you can check your work here in a second. All right, so p to the fourth over s cubed parentheses squared. Distribute that 2, multiply, so p to the eighth and s to the sixth. And then last one, a to the first, x to the fourth over 4 to the first, y cubed. All parentheses squared, so multiplying everything by 2, a squared, x to the eighth, 4 squared, and y to the sixth. So hopefully relatively straightforward still for you. So our next one is one of everyone's favorite. It's our zero exponent. So anytime I take any base, no matter what, to a power of 0, it is always going to be equal to 1. Okay, as long as that base, of course, is not 0. So as an example, if I have 3 to the 0, I don't have to do anything crazy because my base is being taken to a power of 0. So that's just equal to 1. So follow example, I have y to the fourth over y to the fourth. 4 minus 4 would be 0, so this would be equal to y to the 0, and anything to the 0 power is equal to 1. So I want you to go ahead and practice with those last 3. There are some tricks to those last 2, so see if you can figure them out, but go ahead and pause the video now. All right, so w to the 0 and y to the 0, both to the 0 power, so 1 and 1. 1 divided by 1 is equal to 1. Our next one, we have 2 times w plus 1 to the 0 power. So that w plus 1 is the only piece that is being taken to the 0 power. So that w plus 1 becomes 1, but then I still have that 2 multiplying on the outside. So my final answer would be 2. Then last but not least, I have r to the 0 plus z to the 0 plus w to the 0. So those are not all being multiplied and raised to a power of 0. They're individually being taken to 0. So each of those individual terms would be 1, and then I can add 1 plus 1 plus 1, which would be 3. Then I still have that squared on the outside, so 3 squared is equal to 9. So don't just say, like, oh, there's a 0 power, the whole thing is 1. You do still have to pay attention to where those 0 powers fall, and if you might be adding or subtracting or still multiplying by something extra after you take the 0 power. Good thing to look out for. So the very last thing we're going to talk about is negative exponents, and this is both the simplest one and kind of the hardest one for people to understand typically. So negative exponents mean to take the reciprocal. So a to the negative n is the reciprocal of a to the n. So if I have a to the negative n, then that would be equal to 1 over a to the n. Now, a lot of times a misconception is that negative exponents always mean to send a power to the bottom of a fraction and make it positive. But if it starts in the bottom, it actually moves up to the top. So negative exponents mean to take the reciprocal, which truly means to just change the place of the base in a fraction and then change that power to a positive once you make that move. So let's look at an example. So I have 2 to the negative 1. So 2 to the negative 1 is currently at the top of a fraction, because we could also write this as 2 to the negative 1 over 1. So that 2 to the negative 1 will move to the bottom. So it'll become 1 over 2 to the first, which is really just 1/2. Okay, as another example, I have y to the 4th over z to the negative 3rd. So y to the 4th is positive, so it's going to stay exactly where it is. Z to the negative 3rd, though, that's negative, so it needs to move from the bottom of the fraction up to the top. So this is going to become y to the 4th, z to the positive 3. And even though I don't have to write it, I want you all to see this. So when that z moved up to the top, I still have that divide by 1. Because when I move things in the fraction, I don't get left over with 0. I get left over with 1 because everything's being multiplied or divided. But do I still have to write y to the 4th, z cubed over 1? I do not. I can just write this as y to the 4th and z to the 3rd. I don't have to include that 1 at the bottom. So go ahead and pause this video and work out these other 4. See how you do. All right, y'all, let's talk about a few of these to kind of clean our stuff up. So 1 over x, that's 1 to the 1st and x to the 1st. I have that negative 5 on the outside that I'm going to distribute in. So 1 times negative 5 is negative 5. So 1 to the negative 5th over x to the negative 5th. Both of those exponents are negative, so I'm going to switch both bases from the respective places in the fraction. So it becomes x to the positive 5th over 1 to the 5th, which, of course, 1 to any power is just 1. So I can just simplify that as x to the 5th. Then we have x squared over x to the 5th. This one's a little more straightforward. Dividing, so I'm going to subtract the powers. 2 minus 5 is negative 3. X to the negative 3 has got to move down to the bottom, so it becomes 1 over x to the 3rd. B to the negative 2 and c to the 4th. B to the negative 2 is in the top. It's got to move to the bottom and become positive. So this becomes c to the positive 4th over b to the positive 2. And then last but not least, down there at the bottom, we have 2 over 3, and it's being raised to the negative 2 power. 2 and 3 both have a 1 power, so 1 times negative 2 is negative 2. So 2 to the negative 2 over 3 to the negative 2. Once again, both are negative, so they switch places and become positive. 3 squared over 2 squared. So we're almost done, but there was somewhere on the front we left some negative exponents, so let's go back to our dividing. And we got to finish these up. So a to the negative 5th, we now know that would actually be equal to 1 over a to the 5th, because we don't want to leave negative exponents. Negative exponents are bad. And then last but not least, x to the negative 8th over y to the 6th. We can move that x to the negative 8th down. So this would become y to the 6th over x to the 8th. And as always, my cursor does not want to play nice. All right. And that pretty much sums up all of our important and relevant exponent properties. So we're going to be using this in tandem with some of our log material that we're going to learn eventually. But like I said, this exponent property stuff should be a review from Algebra 1 and Algebra 2. But if it's not, of course, please make sure you do lots of practice on that homework that's attached to this notes. And of course, come to tutorials or ask some extra questions in class. But that's all I got for y'all today. Thank you for tuning in.